Hey guys, a couple of months ago I posted a video about SQL Window Functions where I explained how you can write SQL queries using window functions such as rank, dense rank, row number, lead and lag. Now a lot of people liked that video and I received a lot of positive feedback. A lot of you guys reached out to me in the comment section of that video and also on my LinkedIn and Instagram stating that the video was really helpful and they asked me to make another video covering the remaining SQL window functions. And that is why I'm making this video where I want to cover everything that I was not able to cover in the last video. So the contents that I'm going to cover in this video are, I'm going to talk about an alternate way of writing SQL queries using window function. And then I'm going to talk about the frame clause, how you can use a frame clause when writing SQL queries using window functions. We'll then see a few other window functions such as first value, last value, nth value, NTILE, percent rank, as well as CUME DIST. Hopefully with this you will get complete idea about all the window functions available in SQL. As always, before I can start writing queries to explain all of these concepts, if you like what I do, then kindly do consider subscribing to the channel. Also like this video and leave a comment below with your feedback. It really helps the channel to grow and also motivates me to make more interesting and useful videos for you guys. Thank you and let's begin. Okay, so I have created a new table called as product, and this table has 4 different columns. So I have product category, brand, product name and price. Under product category, I have 5 different products. So there is some data related to some phones, and then I have data related to laptops, then some data related to earphones, headphones, as well as smartwatches. Okay, and then I have a column product name where it indicates what is the product name. So I have all the phone names under the category phone. Under laptop category, I have all the laptop names and so on and so forth. And the company to which these products belong, it's mentioned under the column brand, and then the price of these products is mentioned under the column price. Okay, so we are going to use this data in this table to explain all the different contents that we are going to cover in this video. Okay. Let's start by looking at the first value window function. Now, as the name suggests, first value can be used to extract a value or a column value from the very first record within a partition. Okay, so let's say you have a requirement where you want to write a query which will fetch the most expensive product under each category, and it should display this data corresponding to each row of your result set. Okay, then in that case, using first value window function would be a good choice. So let's see how we can write this query. So we start by writing select star from the table name. In this case, it's product. So star will fetch all the columns from this table. So that is okay. And after that, we want to also extract the most expensive product or basically the most expensive product name under each category. So to do that, I'm going to use the first value window function. So I just say first value. Now first value window function will accept one argument. So I need to pass one argument, and this argument is basically the value that is going to get displayed in that column. So I want to display the product name. So I'm just going to use the argument as a column that is product name. And as you already know, when you are using a window function, you need to use the over clause. So it's mandatory to use a over clause whenever you're using a window function. It's not mandatory to specify anything inside the over clause. I can leave it as it is, but the data will not be as what I want. So if I understand this requirement properly, I want to extract the most expensive product corresponding to each category. So for each category, so here I have 5 different categories. So I have phone. So for phone, I have around 10 records here. So under this category, I want to extract the most expensive product based on its price. And then under the category laptop, again, I want to extract the laptop product with the most expensive price. And same way for all the other categories. So I need to partition this result set based on the product category. So that is why I need to use the partition by clause. Okay, so I'm just going to say partition by product category. Now, if I did not use this partition by clause, then what will happen is all the result set of this particular query, that is this table in this case, would be considered as one partition. So totally this table has 27 records. So if I skip this partition by clause, then all of these 27 records would be treated as one partition or one window, and then any window function that we use will be applicable to that particular partition. So in this case, since I'm creating a partition by product category, what SQL will do is SQL will create 5 different partitions for this record based on the distinct values that are present under this column product category. Okay, so I have partitioned my data. Now for each of this partition, in this case for each of this product category, I need to find the most expensive product. So in order to do that, I can use the column price. So I just need to sort the data based on the price in descending order. So to do that, I can just say order by price and then in descending order. So I just mentioned this, and so this should do the trick. And then I'm going to give an alias to this column, naming this like most expensive product. So that's all. Now if I just execute this query, you can see that now I have got all the 27 records. So all the records from this table is still showing up, but there's an additional column that is added, that is the most expensive product. Now let's look at each partition in detail. Okay, so we have partitioned the data based on product category. So the first product category here is showing is earphone. So under earphone, I have 4 different records. And if I look at the price, I know that the record with the price 280 is the most expensive earphone. So, and this 280 is corresponding to the product name AirPods Pro. And that is what is getting displayed in my new column, most expensive product. And this is because first value, what it will do is within a particular partition, it will just go to the very first record and extract whatever column that you have specified inside as an argument. So in this case, I have mentioned the argument as product name. If I mentioned something else, maybe let's say brand, then it would display here as Apple. But since I have mentioned here as product name, it will go to the very first record of this partition and it will take the name, the value that is stored in the product name. So similarly, if I come to the second partition here, headphones, it will see that there are totally 3 records, and under this partition the very first row belongs to this particular row, that where the product name is AirPods Max, and this is what will get displayed in all the corresponding records of this partition. Okay, similarly if I go to the next partition, which is of laptop, I have I think 6 records here, and very first record has the product name as XPS 17, and that is why it's printing XPS 17 corresponding to every record in this partition, and so on and so forth for all the different product categories. Okay, so this is basically how a window function works, and this is basically how you can use first value. Okay, so now let's talk about last value. So as the name suggests, last value will basically fetch a value or a column from the very last record of a particular partition. Okay, so let's say you are asked to write a query where you want to extract the least expensive product under each category corresponding to each record. So almost the opposite of what we did in first value. Okay, so let's try to write the query, but I can basically reuse the same query that I wrote for first value. Okay, so I'm just going to type it here. So I have this query. So this query is basically having just the first value here. Now I'm just going to write another column which will display the last value. Okay, so I'm just going to say last value, and then here I need to pass an argument, same like first value. Last value also needs an argument, and this argument is basically the column or the value that needs to be displayed. So again, I'm going to use the value as product name, and then again we need to use the over clause because window function over clause is mandatory, and then again we need to find the least expensive product under each category. So we need to make sure that this window function will execute for each set of product category. So I need to partition the whole result set based on the unique records present in product category. So I'm again going to use the partition by clause. So partition by product category. Okay, so after this, again I need to sort the data based on its price because I'm trying to fetch the least expensive product. So what I want is the least expensive product should be at the bottom of my partition. So I need to sort the data in the descending order. So again I'm going to say order by price in the descending order. Okay, and I'm going to name this column as least expensive product. Okay, so now if I just execute this query, you can see that the query is executed successfully and there is a new column added that as least expensive product. But if you see properly, this least expensive product is actually not correct. The data is actually not correct. So if I look at all the data corresponding to this product category earphone, I can see that the most expensive earphone is AirPods Pro. Its price is $280, and the cheapest earphone is of $170, which is Galaxy Buds Live. So what I wanted this query to output is that under this column, least expensive product, it should have displayed Galaxy Buds Live in all of these records, but it's not doing that. The reason why it's not doing that is because of the default frame clause that SQL is using. Now, what exactly is a frame clause? But before that, what exactly is a frame? Whenever you're using a window function, the most important thing that window function does is it creates a window, okay, or it creates a partition, and it applies that window functions to each of those partitions. Inside each of these partitions, we can again create some subset of records which is called as frames. So basically a frame is a subset of a partition. So in this case, this particular partition, which is the earphone partition, has 4 records. But the last value window function, when it's going to process all the records in this partition, it's not basically going to use all the 4 records at once. It's going to use all the records which are within its frame. Now I'm going to show you the default frame which SQL uses. So this one is a default frame in PostgreSQL because I'm using PostgreSQL here, but I'm sure it's the same for any of the other major RDBMS like Oracle, MySQL Server, MySQL, or any other. Now I'll modify this query in order to showcase how the default frame clause looks like, and then we will change that frame clause so that our last value function can fetch the data that we want. Okay, so this line is already too long, so let me try to split it into few lines so it becomes more easier for you to read. The frame clause that I'm talking about is actually mentioned inside the over clause, and it's mentioned at the end, that is after you specify your order by clause. Okay, so after you specify the order by clause inside the over clause, you can mention the frame clause. Now the frame clause can be mentioned in a few ways. I'm just going to tell you what is a default frame clause that is used in SQL, okay, especially in PostgreSQL, but I'm sure it's the same in other RDBMS as well. So the default frame clause is range between unbounded preceding and current row. Okay, so this whole statement here, which reads like range between unbounded preceding and current row, is the default frame clause that is used in SQL. So even whether I mention this or I don't mention this, SQL is actually considering this statement. Okay, now I'll explain you what this statement exactly means. So I have something like a range here. Range basically tells what is the range of records that this last value window function needs to consider. Okay, so it's telling the range must be between, that means consider the rows between unbounded preceding and current row. So unbounded preceding means it's basically the rows preceding to the current row, and unbounded basically means from the very first row of the partition. So let's say if your query is executing and if it's processing the very first record, for the very first record, it's going to see that it's going to consider all the rows within the unbounded preceding and the current row. Now unbounded preceding for the first row would again be first row because there is no rows prior to first row, so it will just consider the first row, and the current row again is just the first row. So when SQL is going to process the first record, the unbounded preceding will also lead to the first record, and current row also is the first record. So the frame will only be pointing to this first record. So basically last value will only have access to this particular record, that is the first record, and from this first record it's going to fetch the last value. Since there is only one record, the last value will also be the same as the first value because it's just one record, and that is why both the first value as well as the last value is returning the same output. Okay, now let's say when SQL is trying to process the second record. Okay, now what happens is the unbounded preceding will point to the first record of the partition. So this is one partition, that is basically this whole earphone product category is one partition. Under this partition, the very first record, which represents the unbounded preceding, will be this record where the brand is Apple and the product name is AirPods Pro, and the current row when SQL is processing the second record would be this second row. So when SQL is processing the second record, the last value would have access to these two records, and from these two records it's going to fetch the last value, and the last value between these two records will be the value corresponding to the last record of that partition or that frame, which in this case is the WF1000XM4, and that is what is getting displayed here. Now similarly, when we come to the row number 3, when SQL tries to process the third record, the frame clause would let the last value to access the first 3 records. Okay, because unbounded preceding will point to the first record and current row is the third record. So from the very first till the current record, that is 3 records, and within these 3 records, the last value is the Galaxy Buds Pro, and that is why it's printing Galaxy Buds Pro. And the same thing happens for the 4th record, and so on and so forth for all the different partitions. Okay, and this is why the frame clause becomes very important whenever you're using the last value. Not every window function will really be impacted by this default frame clause. So it generally impacts the last value and also the nth value and also all the aggregate functions, most of the aggregate functions. So in order to fix this, what basically I need to do is, you can see that the reason why last value is not able to extract the proper value, that is the least expensive earphone in this case, is because it does not have access to all the records of this partition. So basically what we need to do is we need to modify this frame clause in order such that it will be able to access all the records, that is from the very beginning of the partition till the very end of the partition. So this unbounded preceding is fine, but we just need to change the current row to something that can point to the very last record of that partition, and that we can represent by saying unbounded following. So basically following means all the records following the current row, and preceding means all the records prior to the current row. So and unbounded means either to the end or to the beginning. Okay, so now if I execute this query just by changing this current row into unbounded following, and you see the output here now, and when I execute this, you can now see that the least expensive product, this particular column, is actually displaying the correct values. So under my category earphone, the most expensive is AirPods Pro, as you can see it's $280, and the least expensive is Galaxy Buds Live, which is $170, and that is what is getting displayed here. Same way, if I go to the next product category, which is my next partition, the least expensive here is the Surface Headphones 2, which is $250, and that is what is getting displayed here. And same thing happens for the laptop category. The least expensive laptop is MacBook Air, that is at the end, that is at the last row, and that is what is getting displayed here as the least expensive product. So just by changing the frame clause, we are now able to extract the value that we wanted last value to extract. I hope this was clear and it was not too much confusing. And there are a few other modifications also that we can do. So whenever we are specifying the frame clause, we can either specify it as a range or we can specify it as rows. So instead of range, I can also specify rows. And if I execute this, basically what rows will tell is, it will consider what are the different rows that needs to be considered within a frame. Okay, and a range is also something similar to that, but the difference between a range and rows will come when there are duplicate records. Okay, so let's say if I am looking at phone, okay, so I must be having some duplicate data here. Yes, so I have some duplicate data here. So let's only consider this phone. Okay, or let me just put a filter condition here. We're saying product category equal to phone, just so that I can explain you better. And I'll just run this. So you can see that instead of range, I'm using rows and it's still printing fine. The most expensive phone is Galaxy Z Fold 3, and the least expensive phone from this data you can see, which basically costs $300, is the OnePlus Nord, and it's displaying properly. Now I'm using rows here, but let's say if I, instead of unbounded following, I just mentioned current row. Okay, and now if I just execute this, I just want you to focus on these last three values, that is 5, 6 and 7. These three values, three records here is basically having the same price, that is $1,000. Okay, and you can see the least expensive product here is different for each row. So for row number 5, where we have the product as Galaxy Z Fold Flip 3, it's printing the least expensive product as the same product. For iPhone 12, it's printing again iPhone 12, and Galaxy S21, it's printing Galaxy S21. Now instead of rows, if I just change it to range, and if I execute this and just focus on this 5, 6 and 7 line, okay, so let me just highlight that again. You can now see that the least expensive product is printing as Galaxy S21 for all the three records. Okay, so this is basically the difference between range and row. What row will do is, whenever we say current row in rows, when I specify here as rows, and if I use the current row, it will consider the exact current row. But what range will do is, if that particular row has some other rows with duplicate values, so in this case this 1000 is repeated in 3 different rows, and why it's considering this 1000 is because we have ordered by that price value. Okay, so since these 3 rows are having the same price, range will consider the last row with that price. Okay, so when SQL is trying to process the line number 5, the last value function will have access to all these 7 records. Okay, so all these 7 records will be within its frame, and within this frame it's going to look for the least expensive product, which is the Galaxy S21, and that is what is getting printed to all these 3 records. But if I had used row here, rows, then, and if I executed this, when it's trying to process the line number 5, it will only have access to these 5 records under its frame, and within this frame the least expensive is Galaxy Z Flip 3, and that is what is getting printed here. Okay, so that is the difference between using rows and range. The only difference would be when you have duplicate data, range will consider everything, all the duplicate data also will be considered until the last row. When you're using rows, it will only stick to that current row. Okay, and there are a few other modifications I can do as well. So I can specify, instead of unbounding, I can specify 2, 3 or any other number, and instead of here also I can just say let's say 2 following, something like this. So what this will do is, it will consider the rows, 2 rows prior to the current row and 2 rows after the current row. So if you are processing row number 3, then it would get 2 rows prior to the current row and 2 rows after the current row. So all these 5 rows would be under its frame. Okay, so these are the different things that we can do when you're specifying a frame, and it's very important to specify the proper frame based on what is your requirement, especially when you're using the last value function, and the same thing will happen when you're using the nth value function. Okay, and also some of the aggregate functions like average, sum, min, max, etc. I hope this was clear and not too confusing. Okay, so let's proceed further. The next thing that I want to talk about is, I'm going to show you an alternate way of writing this window function. So you have seen this query here. So I have used 2 different window functions, first value and last value. And under each of this, I have mentioned this over clause, right? Now, if I had to write a query where I was using multiple window functions, then repeating the same over clause again and again would simply be taking a lot of lines in our code, as well as it would not be the best way of reading a query. An alternate way of writing a window function would be, so what I'm just going to do is, okay, I will just copy this whole query. Okay, so, and I'm just going to print it here. And here, okay, I don't want this, so I'll remove the where clause, or I can keep it as well, no problem. And what I want to do is, instead of mentioning the whole window function here with its over clause and everything, I can use a clause called as windows, and inside the windows clause I can specify everything that I have mentioned in the over clause. Okay, so how I can do that is, after my from as well as after my where clause at the end, but it should be before the order by clause, I can just mention a clause like window. Okay, and then I give a name for that, saying that windows w, I can give any name I want, and then I specify what I need to mention within the over clause. Okay, so I'm just going to copy this whole thing. So I'll just copy this whole thing and I'll just put it here. Okay, so this, everything that I was mentioning in the over clause, I can just mention it here. Okay, and then I don't need to specify everything under this over clause here, but I can just mention this as W. What's happening is this window clause is where I'm going to specify everything that was supposed to be defined inside the over clause, and I'm going to give it a name like W, and this W is what I'm going to specify here. So whenever I'm using a window function and when I need to specify the over clause, I can just specify this alias here. Okay, so let me just remove all of these spaces, and so I'll just bring it in single line, and I'll do the same here. So I'll remove this over clause. And you can see that I did not use the frame clause here, but I can use frame clause here as well. It will not cause any difference to the data. So instead of this, I'm just going to say W, and then I'll just remove all the spaces. Okay, so now you can see that I had this above query where I had this first value and then the over clause, and then I had the next window function, then again the over clause. And if I had 10 different window functions, then I would have specified 10 different over clauses. And in most cases, these over clauses would just be the same. You'd just be repeating the same code again and again. But by writing the same window function in this format, what I'm doing is I'm using a window clause, and inside the window clause, I'm specifying everything that I wanted to mention within the over clause. And then when I'm using the window function, after the over, I just give the alias to that window clause. Okay, and this will automatically consider everything that was mentioned here. Okay, so even if you're using 10 different window functions, you can just use this W to represent whatever you wanted to mention within the over clause. So this will save a lot of your lines within your query, and also it becomes much easier when compared to readability. So let me try to execute this query and see if the data is the same, and you can see that the data is exactly the same. Okay, I just need to make this change. So I'm just going to say unbounded preceding to unbounded following. Okay, and if I just execute this, you can see that it's basically working fine, and it's fetching only for phone. So let me remove this filter condition, let it fetch for all the different categories. And now you can see that I'm having all the 27 records, and the most expensive product is displaying the most expensive product under that category, and the least expensive product is displayed here. Okay, so this is basically an alternate way of writing a window function. Hopefully this was helpful. Okay, so the next thing that we are going to talk about is the nth value. So I'm just going to print this. So what is nth value? So as the name suggests, it's very similar to the first value and last value. First value would fetch a value or a column from the very first record of your partition. Last value would fetch the value or a column from the very last record of your partition. And nth value can fetch a value from any particular position that you specify. So we can specify a position, and from that position or from that row, a value will be extracted. Okay. So let's write a query to do that. And in fact, I'm actually going to copy this same query. So I'm just going to copy this and I'm going to paste it here. And here I already have first value and last value. So I'm just going to create another column here saying that nth value. Okay. And what I'm trying to do here is, so I just want to extract the second most expensive product under each category. So this particular first value is extracting the most expensive product, last value is expecting the least expensive product, and by using nth value, I want to extract the second most expensive product. Okay, so to do that, I'm just going to say nth value, and I need to pass two arguments here. Okay, the first argument is basically the column that I want to display. So in this case, again, I want to display the product name. I can display any other column I want, but this is more meaningful for this query, so I'm just going to stick to product name. And then I want to specify from which position I want to fetch this. Okay, I'm interested in the second most expensive. So from each partition, it's going to look for the second row within that partition and going to fetch the value that is of product name from that particular row. So I'm going to say 2. And then here I just mentioned the over clause. Again, I'm going to use W, and then I just give an alias to this column saying that this will be second most expensive product. Okay, so if I just execute this program, you can see that now there is a new column added here, and this column will always print the second most expensive product from each category. So if I look at the category earphones, you can see that AirPods Pro is the most expensive product and Galaxy Buds Live is the least expensive product, and the second most expensive product is WF1000XM4, and that is what is getting displayed here. Okay, so and the same thing happens here in headphones. So the second expensive product here, basically we have 3 records only, is this WH1000XM4, and that is what is getting displayed here. And when I come to the category of all the laptops, I can see that all the laptops here, the second record for this partition is XPS 15, hence the second most expensive product is printed as XPS 15. Okay, so this is what nth value does. Now instead of 2, if I mentioned 3, then it would go to the third record of each partition, and from that third record it would print the value. So in this earphone, the third record is Galaxy Buds Pro, and that is why it's printing Galaxy Buds Pro. Okay, and this is what happens under each category. Now let's say instead of 3 I just mentioned 5, and in my first 2 partitions I don't have 5 records. So what happens is, in this case, it's just going to return null value. Okay, so it's going to find, it's under each partition, nth value will look for the 5th record, and in that partition if it does not find 5 records, it's just going to return null. So under my partition earphone I don't have 5 records, so it's returning null. Under headphones I don't have 5 records, it's going to return null. Under laptops I do have 5 records, and under this partition it's going to look for the 5th record. The 5th record here is this XPS 13, and it's going to print that XPS 13, and the same thing happens for other partitions. So this is basically what nth value does. And one thing to remember here is, for nth value as well, specifying the proper frame clause is important. So let's say I did not specify this. Okay, I'll comment out this and I'll just close the bracket here with the semicolon. And in this case, by default, SQL will consider the range to be unbounded, preceding, and the current row. And now if I execute this program or this query, you can see that it's, and let's say not 5, I want, let's say, the second most expensive product. Okay, and you can see that it's basically not printing properly. So in the first partition here, I have 4 records. The second most expensive is WF1000XM4. For the last 3 records, it's printing fine, but for the first record, it's not printing fine. The reason for that is when it's processing the first record, it's only, the frame is only having access to the first record, and so within that first record, it's not able to fetch the second record, so it's printing null. But when it comes to the processing the second record, it has access to the second record, so it's printing this, and the same thing happens when it's processing the remaining records. Okay, so that is why whenever you're using last value and nth value, make sure to specify the proper frame clause so you get the data as per what you desire. Okay, so now let's go to the next one and let's talk about another window function, that is NTILE. NTILE basically can be used to group together a set of data within your partition and then place it into certain buckets. Okay, and SQL will try its best that each bucket that it creates within a partition will have almost the equal number of records. Okay, if you don't understand this now, once I write the query, it will be very clear. So let's say I want to write a query where I want to segregate all the most expensive phones, mid-range phones, and all the cheaper phones. So I want to basically create 3 different categories or 3 different buckets, where the first bucket should have all the expensive phones, the second bucket should have the mid-range phones, and the third bucket should have all the cheaper phones. So when you want to segregate your data equally within a few different groups, that is where we can use the NTILE window function. So let's try to write this query. Okay, so I'm going to write this query from scratch. So I'm just going to say select star from the product table. Okay, and then here I'm going to use the NTILE function. So NTILE, and this NTILE function will accept one argument, which is basically the number of buckets that you want to create. So let's say I want to create 3 buckets because my first bucket or the first group of records that I want to create should be for expensive phones. The second group should have all the records which has the mid-range phones, and the third group should have all the records related to cheaper phones. So I need 3 groups or 3 buckets. So I'm just going to say NTILE of 3, and then I'm just going to use the over clause. I'm not going to use the window clause because I'm just going to use one window function here. So I'll just use a single over clause here. So I'm just going to say over clause, and do I need to partition here? I actually don't, because it's telling me that the query is only interested in phones. So we are only interested in fetching the data for phones. We don't need other product categories. So I can just put a filter condition here saying that where product category equal to phone. So We are only interested in this particular category. So inside my over clause, I don't need to specify partition in this case, but I need to specify the order by clause, and the order by class should be based on the price of each phones, so that we know at the top we have all the expensive phones followed by all the less expensive phones. So I just say order by price in descending order, and then I'm going to give an alias saying this will be something like my buckets. Okay, so if I just execute this query, you can see that I have this new column created buckets, and it has values like 1, and then I have something like 2, and then I have 3. So totally I have 10 records because I have 10 phones mentioned in this table under this category phone. And what SQL is doing is, since I have specified 3 buckets, okay, so all these 10 records, it will try to equally split among these 3 buckets. Now we cannot equally split 10 into 3 buckets, and so that is why what happens is it will give precedence, or it will give priority to the first bucket. So the first bucket will get 1 additional record, that is 4 records here. The second bucket will get 3 records, and the third bucket will get 3 records. Okay, so this is basically how NTILE works. It basically groups together different sets of rows depending on how many buckets you want to create, and under each bucket it will try to provide equal number of records as much as possible. So let's say instead of 3 buckets, if I wanted to create 5 buckets, okay, so now if I execute this query, you can see that I have 1, 2, 3, 4, and 5. There are 5 different buckets, and since I have 10 rows, each bucket has been equally distributed with 2 records each. So our requirement for this query was that we wanted to write a query which would display all the phones under the most expensive category, mid-range category, and cheaper category. So we'll stick to 3 buckets, and I have all these buckets created here, and then I'm going to put this inside a subquery, and in my outer query I'm just going to say I just am interested in the product name, okay, and then I'm interested to say whether this product is expensive, mid-range, or cheaper ones. Okay, so for that I'm just going to use a case statement. Okay, but before that I'll just put all of this into my subquery. So I'll just push this ahead, and I'll close the bracket. I'll give an alias like x, and that's it. So here I'll use a case statement. So I'm going to say case when x dot buckets equal to 1, then I want it to be printed as expensive fonts. Okay, and let's say if I just copy this here and here, and then I'm going to say and okay, so I just click something. So here I'm just going to give a name for this, something like phone category. Okay, and I'll just say this. So if this is 1, then it is expensive. If it is 2, then it will be mid-range phones, and if it is 3, then it will be cheaper phones. Okay, so I'll just execute this query now, and you can see that I'm having 10 records, and under this column phone category, it's saying that these 4 phones, that is Galaxy Z Fold 3, iPhone 12 Pro Max, Galaxy Note 20, and iPhone 12 Pro are the expensive phones. Then I have 3 phones under the mid-range category, and then I have the cheaper phones at the end. Okay, so this is basically how we can use NTILE function whenever we want to group together a few records into some buckets. Okay, so now let's talk about the CUME DIST function. CUME DIST basically stands for cumulative distribution. It's basically a mathematical formula. What this will do is it can basically be used to identify the distribution percentage of each record with respect to all the rows within a result set. So the CUME DIST function will always provide a value which is within a range of 0 and 1. Now, the best way I can explain CUME DIST function is by writing the query, and then I'll explain you the formula and where we can use this CUME DIST function. So let's say you have a requirement where you want to fetch all the products which are basically constituting the first 30% of all the data in your products table based on price, And then in this case, we can use the CUME DIST function. So let's try to write a function. So before that, let's try to understand what we are trying to do. So I have this products table. It has the list of all the products. So let me just do a select star from products. So select star from products, product. Okay, so I have all of these products. So you can see I have 27 records. There are all sorts of products. So I don't need to partition based on different category, because this query is for the entire product table. So what it's telling is, out of all your product table, if you wanted to fetch what are the products which are constituting the first 30% of your data. So how do you identify which is the 30% of your data? Okay, and in this case, it's just 27 records. You might be dealing in real-time projects where you have thousands of records or millions of records. So if you want to find out 30% of that data, and in that 30% of the data, if you wanted to know which are the products that constitute this 30% of the data, then in order to write this kind of query, we can use the CUME DIST function. Okay, so let me try to write this function. So I'm just going to say select star from, and I'll say CUME DIST, and CUME DIST, we don't need to specify any argument. It does not accept any argument. And then I just say over, and inside over, I don't need to specify a partition, because I want to I want this CUME DIST window function to run on the entire result set. So I just need to specify an order by clause. So because it's told that I need to sort the data based on price. Based on the price, I want to identify which are the first 30% of the whole data, the products that belong to the first 30% of the data. So I'm just going to say order by price, and in descending order. And then I'm going to give an alias for this, something like, let's say, CUME distribution. Okay, something like this. And if I execute this query, we can see that what's happening is there's a new column created, and this value might scare you and it might not be very clear on what this value is, but I'm going to explain you. So basically, just for better understanding, what I'm going to do is I'm going to create another column here. The same thing, I'm just copying that, but here, instead of displaying this in this decimal format, I'm just going to convert it into a percentage format. Okay, so to convert that, I'm just going to use the round function. I'm just going to say round of this, and then I'm just going to convert it to numeric, and then I'm going to say I'm going to multiply by that by 100, because it's in the form of percentage, and then I'm just going to fetch 2 decimal points. Okay, so this column, I'm just going to name it like CUME DIST percentage. Okay, so if I execute this, now I think this will be more clear to understand. So basically, these both columns are the same. It's having the same data actually, but just that this column, I have just modified that by changing it into in percentage format. Okay, by multiplying this value by 100 and then only fetching the first 2 decimal points. Okay, so basically this column represents the CUME DIST value of each of the record in this result set or in this table. Okay, so the first record, which has a CUME DIST of 0.03, which basically corresponds to 3.70%, means that the distribution of this particular row when compared to the entire result set is 3.7%. So meaning that this row has a distribution of 3.7% compared to the entire result set of this 27 records. Okay, and same way, if I wanted to identify the first 30% of the records of this result set, then I can just do that by less than 30%. So all this, so because I don't have anything like 30%, so less than 30% would be all of the 7 rows. The first 7 records here basically constitutes the 30% of my data from this table. Okay, now we are dealing with a very small table here, so it might seem not that useful, but when you're dealing with thousands of records, and if you have been given a task of fetching maybe the last 20%, so especially in the sales data, if someone tells you that in the sales data, go and fetch the data for the 20% of products which are performing very badly, then you can go and use the CUME DIST function to fetch the last 20% of the data, and then maybe extract whatever columns or values that you want in order to know which are the products that are performing badly. So that is where CUME DIST can be really helpful. Now for our query, what we want to do is we want to fetch all the product names which constitute the first 30% of the data in this table. So I have the CUME DIST value displayed here. Now in order to fetch the first 30% of the data, I can just use a subquery. So I'm just going to say select, and I'm only interested in the product name, so I'm just going to say product name, and then I want the CUME DIST percentage. So I'm just going to copy this big column name, so this one, and then I'm just for more understanding, clarity, I'm just going to concatenate it with a percentage symbol. Okay, and then I'm going to give an alias to this. I'm just going to call it with the same thing. Okay, so I can just put it inside a bracket just for better clarity, and after as I'm just going to leave a space. So this is my column, and after this I'm just going to say from, and I'll just remove this bracket. I'm just going to move this to the right, so just to make it more clear, and I'm going to give an alias like X. Okay, and here I'm only interested in the first 30% of the data, so I'm just going to say where X dot, and I'm going to use this particular function here. So I can use this one or this, so maybe I'll try to use this. So I'm just going to say this one is less than, so 30%. So I'm just interested in less than or equal to 30%, right? So this one. So if I just execute this program or this query, you can now see that I'm able to extract the query where it's returning me all the product names which constituted the first 30% of the data in my product table. Okay, so this is basically how we can use CUME DIST function. I think I forgot to explain you how this CUME DIST is calculated. So let me go back and run this query here. Okay, and I have this data here. Now this is a formula that is used to do this calculation, and the formula is pretty straightforward. So the formula is, what it will do is, and I have just mentioned it here. So this is a formula. It just basically takes the current row number and divides it by the total number of rows. So when the SQL is trying to process or find the CUME DIST of the first row, it knows that this belongs to row number 1, so the row number is 1, and it knows that the total number of records in this table is 27. So it's just going to do 1 divided by 27, and hopefully you should get this output. Let's just try to check that. So I have my calculator here, and I'm just going to say 1 divided by 27, and you see that I'm getting 0.037037, something like that. So if I see here, and that is exactly the value. So for every record, it's just going to divide the row number divided by the total number of rows until it finds a row where there are duplicate values. So let's say row number 4 and 5. Okay, so as soon as it finds a duplicate record, what it's going to do is, instead of considering the row number of the very first record, it's going to see how many duplicate rows are there. So here I have 2 duplicate records. So, and the duplicate record is based on what you have mentioned in the order by, and the order by I have mentioned is this price column. So the price is 2000 for both these records. So it's going to, the row number it's going to consider is of the last record, that is the record number 5. So it's going to do 5 divided by the total number of rows, 27. So let's try to do that. So if I do 5 divided by 27, I'm going to get 0.185185, and that is what is getting displayed. And this CUME DIST will be common for all the duplicate records, or all the records which has this duplicate value. Okay, so this is basically how the CUME DIST value is calculated. The formula is pretty simple. I hope this was clear and not too confusing. So let's proceed. Okay, so now let's talk about the last function that we are going to cover in this video, that is of %rank. Now %rank, as the name suggests, basically stands for percentage rank. It basically provides a relative rank to each row in the form of percentage. So it's kind of like a percentage rank for each row in your result set. Okay, now the %rank is almost similar to CUME DIST, but the formula to calculate %rank is slightly different from that of CUME DIST. So to understand this better, let's try to write a query. Okay, so let's say I want to write a query and I want to identify how expensive is a particular product. So in this case, let's take the product as Galaxy Z Fold 3. I want to identify how expensive is Galaxy Z Fold 3 when compared to all other products. Okay, in my products table. To write this kind of output or this kind of query, I'll just use the %rank function. So I'm just going to write the query like select star from product, and here I'm going to use the %rank function. So I'm just going to say rank, and again this will not accept any arguments, so I can just say over, and here inside over I'll just order the data because I want to know how expensive I want to sort the data based on its price. So I'll say order by price. I'll leave it in ascending order. Let the phone with or the product with the most expensive price be at the bottom, and I'm going to give an alias to this, something like percentage rank. Okay, so if I just execute this, you can see that I'm getting the data, and there's a column that is added at the bottom here. There is a lot of data here. It's not really very clear, right? So again, what I'm going to do is, as I told you, the data that is shown by percent rank is also again in the percentage. Basically, it represents a percentage rank. So we can just represent this decimal point number into more meaningful way, that is by converting it into a percentage. So to do that, again, I'm going to use the round function, same like how I did in the previous function, that is CUME DIST. So here I'm just going to convert this to numeric, and then I'm just going to multiply this by 100 to convert it into percentage, and then I'm going to consider only 2 decimal points. So and then I'm going to name this something like per rank, okay, or something. The naming is not that good, but let's use it for now. And you can see that I have 2 different columns. The last column is more meaningful, and this, as I told you, the formula to calculate percent rank is slightly different. Now the difference is that the first value, the value that is shown, or the value that is calculated by percent rank or by CUME DIST, will always be within a range of 0 and 1. And in percent rank, the first record will have the percent rank value as 0, and the last record would generally have 1. It's not mandatory to have 1, but in most cases it would have 1. Now, what basically the calculation formula here is, it's going to consider the row number, that is when it's processing the first row, it's going to consider the row number of the first row, and it's going to do a -1. So row number 1 minus 1 is 0, and then it's going to divide it by the total number of rows minus 1. So the total number of rows in this table is 27. Again, -1 is 26. So here current row 1 minus 1 is 0, so 0 divided by anything is 0, and that is why it's getting 0. Okay, when it comes to the second row, what it's doing is it's calculating row number, in this case is 2. 2 minus 1 is 1, and 1 divided by 26, because total rows is 27, it's again subtracting by 1, so it's 26. So it's going to do 1 divided by 26. Let's go to our calculator and let's check it. So 1 divided by 26, it's returning 0.03846. 0.03846. So this is what it's getting displayed. So this is basically how the calculation of percent rank works. It's just a simple mathematical formula, and the same thing happens for all the different rows. Okay, so the formula of calculation of percent rank and CUME DIST is different, but they're almost identical in their functionality. So let's say if I wanted to identify how expensive is Galaxy Z Fold 3. So where is Galaxy Z Fold 3? I can see that I think here. Okay, so Galaxy Z Fold 3 is 80.77% more expensive than all the other phones that are available in this table. So this is basically what percent rank value means. Okay, so if I find a value something like, let's say, Galaxy Watch 4, I can say in other words that Galaxy Watch 4 is 38.46% more expensive than all the other products in this table. This is how we can use the percent rank function. Okay, so now in order to define our query, what we wanted to do is, again, I'm going to use a subquery here. So I want the product name, that is should be my product, and then the percentage. So I'm just going to display per rank. Okay, and then I say from, and I'll just move this to the subquery, and I'll give an alias like X, and here I'm going to say X dot this per rank. Correct, it should be okay, I don't need the per rank. I want to know what is a percentage, how expensive is Galaxy Z Fold 3, right? So I'm just going to copy this product name, and here I'm just going to say product name equal to this particular value. Okay, and if I just execute this, you can see that it's telling Galaxy Z Fold 3 is 80.77% more expensive than all the other products in this table. So this is basically how we can use %rank and also all the other window functions. Hopefully this video was clear. You got good idea about window functions. If there are any confusions, and I believe there would be a lot of confusion because it's not very easy to understand all of these concepts at once. You need to work, you need to especially work on some projects where you'd be using all these window functions to completely get a hold of this. But I hope the syntax and frame clause and the alternate way of writing window functions was very helpful. If you found value in this video, then do consider subscribing to the channel. Also like this video and leave a comment below with your feedback. Thank you and have a good one.